This video is going to start a discussion on how to name enantiomers, and we talk about this in order to be able to identify which enantiomer is which. And one of the things that we're going to have to do first is to take a look at all of those groups that are attached to the chirality center directly. So these are the atoms themselves that are attached. We're going to be taking a look at those, and we're going to be using their atomic numbers. So that's going to be really important to figure out what priority they have. So if they have a higher atomic number, we're going to have a higher priority for that atom. And these priorities are going to establish how we are going to tell whether this enantiomer is going to be designated as R or S, or whether this chirality center is R or S if we have multiple chirality centers. So for the first thing we're going to do, we're going to look at these atoms directly attached to the chirality center. So we see we have a bromine, oxygen, a carbon, and a hydrogen. So bromine, its atomic number is number 35. This is where we're starting over here with the bromine's number 35, oxygen, atomic number 8, carbon, number 6, and hydrogen is atomic number 1. So the higher atomic number is going to be a higher priority. So bromine with a 35 as its atomic number, that is going to be our priority 1. So we're going to put that as 1. For oxygen, it's coming in at the second priority because it has the second highest atomic number. Carbon has the third highest, and then hydrogen is last because it has the lowest atomic number. So if you do have a hydrogen, it'll always be number 4 because you can't get much lower than atomic number 1. And so for this one, we assign our priorities. You're always going to be able to have 4 different priorities. So we'll talk about when, a few of these atoms may be the same, and then what we look at next in the next few videos. But for this video, we had all different atoms attached, and so we could just look at the atomic numbers and assign the priorities to them. So we're always going to have the 4 priorities. Then what we're going to do, and why it's important to assign the priorities first, we're going to end up putting priority 4 in the back. So that's one of the things we have to do in order to name whether this chirality center is R or S. We do have to put that priority 4 in the back. So what we've done here is we've just taken the molecule and flipped it. So we brought the CH3 over kind of to the right hand side, which means that the OH would be on the left, and then the H that was going out is now going back, and the bromine that was going back is now going out because we did a flip, horizontal flip of that molecule. So now priority 4 is in the back. That's good. What we're going to do after that is look at the order of groups 1, 2, and 3. So once you bring 4 to the back, you ignore 4. You don't have to worry about 4 anymore. Once it's in the back, you're just focusing on groups 1, 2, and 3. And so if we are going to look at these groups, we're looking at the order of them. So to see if they're going to be in a clockwise orientation or counterclockwise. So we're going to start at 1, we're going to go towards 2 and 3. So to do this, because the priority 4 was in the back, you can look at the molecule like this. You could alternatively look at the tetrahedral piece kind of like this. And so what's different about these two is that the first one, we're kind of looking at it more like we would on a paper for the tetrahedron, with 1 bond out of the page, 1 bond back, and then 2 in the plane. So these would be the 2 in the plane. This would be out, this would be back. And then how we could look at it is in this orientation where we have actually the 3 of them kind of in the same plane, and then the H, you can just barely see the H at the back there. So those are, either way, you can still do the same thing. It might be a little bit easier to see clockwise or counterclockwise if we look at it on this representation, which is why I ended up doing that one as well. If we want to kind of trace for the model kit purposes, what's what, we have our bromine is going to be the green, so that's in both of them. And then the oxygen is going to be the red ball in both of them. I made the CH3, the blue one. And so that's what's happening for them. So you can kind of trace what they would look like in that model kit. You can build it out yourself if you have your model kit. That would be great. What we're going to do, so once we get it to that orientation, now we have to really figure out what orientation it is in terms of clockwise or counterclockwise. So we're taking a look. We start at number 1, and then we go to number 2. So number 2 is this way. And then from 2 to 3, we're going this way, and then from 3 back to 1, we're going this way. Remember, we're ignoring 4 because it's in the back and we don't have to worry about it anymore. So with that, we're going in this type of motion, which is not the way that clocks go. So clocks generally, I mean, they always go this direction, and so that would we call clockwise. Counterclockwise is the opposite direction, and that's what we have here. So counterclockwise, we're going with when we're counting priorities 1 to 2 to 3 and then back to 1, we're going that counterclockwise motion. That's going to mean that this is going to be an S chirality center. So we would say that that chirality center is S. If we were counting the groups and say our priority 2 was over here and then our 3 was here, we'd be going a clockwise direction and that would be our R enantiomer. So we had to do everything up to this point. We had to assign the priorities correctly. We had to do our put our priority 4 in the back correctly, and then we also had to figure out if it was clockwise or counterclockwise correctly. So a lot of steps to just get whether this chirality center is going to be an R or an S. So to get this one letter, we had to do a lot of things, but it really matters in terms of naming them. So we have to be able to say if this chirality center is facing this way or if it's the other way. And this is our kind of standard way to do it. And so that you'll have some practice with this, but make sure, and I think that probably one of the harder parts is this clockwise, counterclockwise, but just remember to ignore 4 once you put it in the back. You just ignore it. It's from 1, 2, and 3 that you're trying to find out if those are clockwise or counterclockwise, and that's going to get you your R or S.